Now let's count the elements in an array. So let's consider this array A1 to AN, and how many elements are in this array? It's this one is pretty trivial. It's 1, 2, and then you can count the last one is n. So therefore it's just n, right? Or you can use the formula n minus 1, and don't forget to add 1, so which will turn out to be n. So you can either just count or just m plus m minus 1, and don't forget to add 1, which is just the n. What about this subarray like A6 to A18? We just counted 18 minus 6 plus 1. 18 minus 6 is 12. 12 plus 1 is 13. So there were 13 elements in this array. If m is in between 6 and n inclusive, what is the probability that a randomly chosen array elements is in this subarray? So what is the chance that choosing one element is in this set, in this subarray, right? So therefore we need to count how many are there and then divide it by total number of elements in the array. So therefore we are gonna, we do know the total elements in the array is n. So how many elements are in here? So m minus 6 plus 1, right? M minus 6 plus 1, which is m minus 5 over n. Right? So now let's take a look at what is the probability that a randomly chosen array element is in the subarray shown below if n is 47. Okay, n is 47. Now, this notation means the greatest integer less than or equal to x. So in this case, let me do a couple examples to demonstrate what that means. For instance, when we say greatest integer of, say, 1/2, that means you want to find the greatest integer that's less than or equal to 1/2. So in this case, this has to be 0, right? 0 is the greatest integer less than or equal to 1/2. Now if you say the greatest integer function of 1, so that means 1 is the greatest integer less than or equal to 1. So when this is integer, it actually will be itself. Otherwise, you're going to find the integer that's less than or equal to this guy. So that's what this function is. Now maybe let's do one more example. So suppose you have negative 0.5, okay, negative 0.5. So you're looking for the greatest integer that is less than or equal to negative 0.5. Suppose 0 is here, negative 1 is here, negative 2 is here. Negative 0.5 is right there, okay, negative 0.5. So what is the greatest integer that is less than or equal to negative 0.5? Negative 1 will be it. So therefore this will be equal to negative 1. That's the little explanation of this function, which is called the greatest integer function, or sometimes we'll also call it floor function, okay, floor function. We are trying to find the number that's below it, okay, let's call it, it's also called floor function. So I'm going to erase that. All right, so now let's take a look at what is the probability randomly chosen array element is in this subarray. Okay, let's count, okay? So n is 47. Let's first find this guy, the floor of 47 over 2. So let's do a little algebra somewhere here. So let's do it here. 47 over 2. Okay, so 47 over 2 is like 23.5, and the greatest integer function of 23.5, this is actually 23. Okay, so this is A23. Now the next one is add 1, right? So therefore this is actually A24, and so on and so forth. The very last one is AN. Okay, and n is 47, I'm sorry, so we just say 47 A47. Now, because the total, so n is 47, now what is the probability that a randomly chosen array element is in this subarray here? So we do know the total, n is 47, that means there are a total 47 elements, right? And now, how many elements are from here to here? 47 minus 23, 47 minus 23 plus 1. So this 47, which is 25 over 47. So, all right, that's a problem that's related to the greatest integer function. Let's look at the very last example. What is the 23rd element in the array, in this array? So I certainly do not want you to count 1, 2, 3, and so on and so forth. Find the 23rd one, right? So let's call the x as the 23rd one. So x, so ax. Let's say somewhere here ax, a of x. That's the 23rd one. So by the counting formula, we know x minus the 18. Don't forget to add 1. There are 23 numbers there, right? So that's the equation that we want to set up. So x minus 17 equals 23. So x is actually 40. So what is the 23rd element? It will be A40.